Heyo, it's Mr. Otwell, the Math Master, helping you master math. And in this video, I will be answering some questions I had from an assignment I gave to my students about COVID-19. So there's a couple of questions that was missed quite often, and I wanted to go ahead and address those. And then another spot in the assignment, I just said, what are some additional questions you might have after all of this? And so I just want to give you my perspective from a mathematician. I'm by no means some healthcare professional or anything like that, but I do a lot of research about it. The data is very interesting to me, and my wife is an ER nurse, so it's a subject that's very close to home. Okay, so one question that I had was just a question about exponential functions and how we can project some things. So the question was, what if there are two people with a confirmed case of COVID-19 with the average growth rate of 1.25 per day? How many cases could there be in 14 days? So the function that we're going to use to model this is our exponential function, where A is our initial amount and B is our growth rate, or it could be decay rate, it just depends. So for this problem, our initial amount will be our initial amount of people who we have confirmed COVID. So that's 2 people, that's our initial amount. So we can just say A is equal to 2, and our B is 1.25. I didn't make y'all do any sort of crazy determining what that number is. I just wanted to make it a little easier for us here. So B is 1.25. Our x in this case is days. X is usually time for an exponential function. In this case, it is days. We're asking about how long did it take, how many cases will there be in 14 days? So our x that we're going to use is 14. So to use all this amazing information here, we're going to be looking for f of 14. So we're going to substitute 14 into x, into our function f of x. Our a is 2, so we substitute 2 in for a. Our b is 1.25, so we substitute that in there. And our x is 14 days, because that's what this question says. There's 14. That's close enough. So what do we do first? Do we do 2 times 1.5 first? Or do we do 1.25 to the 14th power first? Yes, we just need to remember order of operations here. So 1.25 to the 14th power is approximately, this 2 just stays the same, it's approximately 22.74. I wrote approximately here because I rounded this. It just makes this easier. So 2 times about 22.75 gives us about 45 people. So the other question that was commonly missed was what type of function models the total amount of cases over time. This was the graph of that. A lot of people said exponential, but if you kind of just looked at the very first piece of the logistic curve, then yeah, it would be exponential. But if we're looking at the whole thing over time, the total cases over time, this is called logistic growth. This is called a sigmoid. It's mentioned in the YouTube video that I had my students check out. I can link that down below for anybody who is interested in that video. It's really great just to show you generally what's happening in terms of how the math works. So this is called the logistics function. If you would have said logistic growth, logistic anything, I would have given you credit. So that's going to wrap it up for the most commonly missed questions. If you want to know what my response was to my students' questions about COVID-19 in general, go ahead and check out the next part of my video concerning this assignment. And just remember, really the data is always changing. So it's potential that by the time you even watch that video, things have changed. But really, I wanted to do my best to give you good data that I've researched a lot. And as always, I'll catch you in the next video.